Hello students, welcome to Saurav Sir's classes. In this video, I will be solving the following question from ISS 2017 paper 3. Now here we have to show that this stratified population mean y bar st, which is equals to summation h runs from 1 to k yh wh yh bar, where this yh bar is the simple estimator of simple estimator yh bar of hth strata. Then we have to show that this y bar st, it is the unbiased estimate for population mean capital Y bar. So this y bar st is an unbiased estimation of capital mean population mean capital Y bar, where wh, this is the proportion of population units in the strata, and k denotes the total number of strata in the population. Now then after this we have to derive the sampling variance for y bar st and state how we would unbiasedly estimate the same. Now we have, from the question, we have y bar st, this is equals to summation h goes from 1 to k wh yh bar. Now expectation of taking expectation both sides, so taking expectation on both sides, we would get expectation of y bar st, this is equals to summation, this h goes from 1 to k wh into expectation of y h bar. So now this wh, this is the proportion of population unit in the kth strata, so wh is equals to nh, where nh is the population unit of hth strata, so nh divided by capital N. So we get this expectation of y bar st, this is equals to 1 by n into summation h goes from 1 to k nh into, now this, as we can see here, this y bar h is the unbiased estimate, so expectation of yh bar, it would be into capital YH bar, that is the, which is the population mean for hth strata. So capital YH bar, it is the population mean for hth strata, and so we have 1 by capital N summation h goes from 1 to k nh into yh bar, which is nothing but our capital Y bar. So thus we get our expectation of y bar st is equals to this population mean, that is capital Y bar, that is y bar st is the unbiased estimator of, so y bar st is the unbiased estimator of population mean capital Y bar. Now if we name it as equation number 1, then from equation number 1 we would get variance of this y bar st, this is equals to summation, again h goes from 1 to k, this wh square into variance of this y bar h. Now since the sample being drawn from a strata, it is independent of the sample being drawn from other strata, that is, since all the samples have been drawn they have been drawn independently. Therefore, here we are not writing the covariance term, because covariance of y I bar yj bar, this is equals to 0 for I not equals to j, where I and j belongs to 1 to k. So this covariance term, it would be 0. This covariance term is equals to 0. Therefore, we would get our variance of y bar st. It is equals to summation h goes from 1 to k wh square into variance of yh bar. Now, since the sampling in each strata, it is done with randomly, that is using simple random sample, so that is, suppose it is the entire population which is divided into the strata like this. Now the sampling from each of these stratas, it is done with the process of simple random sampling, while even though the overall sampling method is the stratified sampling method, the sampling method used to obtain the sample from each strata, it is simple random sampling. So therefore we will have two cases. The first case is in case of simple random sampling without replacement, that is SRS WOR. So in case of simple random sampling without replacement, we will have our variance of YH bar. This would be equals to capital NH minus small n divided by capital NH into small n into sigma h dash square, where this sigma h dash square, this is equals to 1 by capital NH minus 1. So the sigma h dash square, it is equals to 1 by capital NH minus 1 into summation j runs from 1 to capital NH. So j runs from 1 to capital NH into YH YHJ minus YH bar whole square. So the sigma h square is equals to this, or it is equals to capital NH divided by capital NH minus 1 into sigma h square. So we get our variance of YH bar, this is equals to NH, capital NH minus small nh divided by capital NH into small nh into sigma h dash square. So now substituting this value in our equation, say 2, we would get our variance of y bar st. We would get our variance of y bar st. This is equals to summation, thus h goes from 1 to k wh square into capital NH minus small nh divided by capital NH into small nh into this sigma h bar dash. So this is the variance y bar st, where the sigma h dash square, this is equals to nh divided by nh minus 1 into sigma h square. That is sigma h dash square, this is equals to 1 by nh minus 1 into summation j goes from 1 to nh yhj minus yh bar whole square. Similarly, in case of simple random sample with replacement, so in case of simple random sampling with replacement, we would get our variance of y bar st, this is equals to summation, this h goes from 1 to k wh square into sigma h square divided by nh, where this sigma h square, this is equals to 1 by capital NH into summation where j goes from 1 to NH, j goes from 1 to NH, then we would have y hj minus yh bar whole square. So sigma h squared is equals to 1 by capital NH into summation j goes from 1 to NH into j goes from 1 to NH yhj minus yh bar whole square. So this variance of y bar st in case of simple random sampling with replacement, it is given by summation h goes from 1 to k wh square into sigma h square divided by small nh. Now next is the estimated variance of y bar st. Estimated variance of y bar st. Now in case of simple random sampling without replacement, we would have this expectation of this small sh square, where the small sh square is equals to our sigma h dash square. So expectation of small sh square, this is equals to capital sh square, where this, so expectation of small h square it is equals to capital sh square, where this capital sh square is equals to sigma h dash square. So this, from here in the previous where we have written sigma h dash square, it is nothing but our capital sh square, and in case of simple random sampling without replacement, expectation of small sh square, it is equals to capital sh square, where this small sh square, this is equals to 1 by nh small nh minus 1 into summation j goes from 1 to small nh yhj minus yh bar square. So sh square is given by this small sh square is given by this. So we would have our estimate of or estimated variance of y bar st denoted by v cap y bar st. This would be equals to summation, this h goes from 1 to k wh square into variance of v cap of yh bar, where this v cap of yh square, that is the estimated variance of yh cap YH bar, this would be equals to, so estimated variance of YH bar, this would be equals to NH minus small nh divided by capital NH into small nh into small sh square. So this is the estimated variance of YH bar. So the estimated variance of Y bar ST, this would be, or V cap Y bar ST, this would be equals to summation H goes from 1 to K WH square into NH minus small nh divided by capital NH into small nh into small sh square. So this is the variance of estimated variance of Y bar ST in case of simple random sampling without replacement. Similarly, in case of simple random sampling with replacement, that is SRS WR, we would have this estimated variance of Y bar ST. This would be equals to summation H goes from 1 to K WH square into SH square divided by NH, where SH, as said before, is equals to 1 by NH minus 1 into summation J goes from 1 to NH YHJ minus YH bar whole square. So this is the estimated variance of Y bar ST.